In this next installment, we'll talk a little bit about tire treads. Now, generally speaking, the AP does not ask questions about tire treads, but this is some of the most useful information you can have, not only in maintaining your own vehicle, but safety and driving. And it's something that's actually extremely relevant in many regards, as you'll see. So tire treads themselves, you'll notice that there are a variety of grooves in different tires and different patterns, and they're designed to do different things. But ultimately, we've learned about hydroplaning and the problem of hydroplaning. What the treads are designed to do is provide a channel for the liquid to form so that the rubber can meet the road. Otherwise, the tire would be sitting on top of the water or the snow. And so the tire tread is designed to provide a conduit so that the rubber can actually push the liquid or the snow out of the way so the rubber hits the road. And you might suspect then that the tire like this has a lot of volume of crack space, and so that's for like snow. And this tire here there's not very much crack space at all, and a lot of rubber meeting the road, and this is what we might call a performance tire for racing and so forth. And then we have varying degrees of all season and all weather tires for different applications. You could see that this type of tire that has this sort of thing, the grooves that are circumferential, they run around the circumference, are designed just to push the water a little bit in this direction or a little bit in this direction as it's on the road, and so forth. So that's what the tread patterns do. And so when I just mentioned hydroplaning before, and you see that when hydroplaning happens, there's liquid between the tire and the road. And so since the water molecules are all these little tiny molecular points, they can rotate, and there's nothing, they can rotate with the tire so the tire doesn't gain any traction there's no friction for the tire to actually pull off the road. So which means if you slam on the brakes, the car is just going to float on top of the water. Or if you're going very, very quickly, the tires are going to come off the road and there's going to be water underneath and you can't steer. And so the tire treads are designed to push that water out of the way to end the hydroplaning. Now, there's also an issue of friction and tire inflation. And you can see in this picture, there's three different depictions here. This one's overinflation. And so there's a bulge here in the center part and the tread wears off. And here where there's proper inflation, you can see there's more of a straight line. And this is underinflated, well, it's concave here at the surface. And the result is, if you look at the pressure patterns of the tires on the road, well, you could depict this one. The higher pressure is dark color. And so that matches the geometry of being underinflated. And if you look, there's just a lot of pressure in a small area, but low pressure everywhere else, so it's not going to push water or snow out of the way. If you look at this tire here, there's a tremendous amount of pressure running across the tire. But all around, you've got the reds, oranges, and yellows in this picture, as opposed to the little bit of red, orange, and much more the yellow, lower pressure. And that lower pressure can happen because the tire is more spread out. And so when we look at these different tires, this one is underinflated. This one is overinflated. And you can see here that most of the pressure is in a very, very small point in the center from the overinflation, and this is proper inflation. And again, you see that because the pressure numbers are much, much smaller all around. Now we can talk a little bit about tire wear. There's a lot of information on this page, but we'll look up here first. This depicts a tire, and as it goes over a surface, the rubber flexes like so. And if you look at this blow-up area here, there's different levels of force that are applied on the tire, and the tire is deformed. But what that causes the wear on the tire, or an ablation of the tire. So the tire ablates and gets rid of these tiny little particles. And of course, there's also variation depending on, and so in this case, you've got a large vertical load, a heavy car, a very heavy loaded car versus an unloaded car. And you could see then that there is less flexion on the tire, and then there'll be less ablation. So the tires in this case will not last as long as these will, because these are being flexed more. But you can also see there's much more traction, much more friction. The tires here are not going to slip as much as they will here. But this does relate to a larger environmental problem that we are coming across. It turns out these little particles, which are depicted in this diagram, this is something that some inventors have made to attach to cars, and this is a tire. When the tire is running, it's designed to electrostatically collect the rubber particles that come off the tire as the tire drives. Now, what we find is that we've determined that there are more than 6 million tons of this kind of rubber ablation gets into our waterways every year. So the tire, these little particles, if they're not collected, which they're not, this technology is not being used on vehicles yet, but the little dust particles land on the road, and when it rains, the rain washes, and the runoff washes the rubber into the waterways, and that creates a huge problem. What they've discovered in like the Seattle area, Seattle, Washington, is that on heavy rainy days, this rubber goes into the waterways and into the Puget Sound and the waterways, and there's massive kill-offs of salmon. And so they've looked at this in detail, and they've identified the chemical that's inside the tires, and ironically, the chemical that is responsible for killing the salmon is the very chemical that's used to help make the tire last longer. And so the rubber flecks come off, they go on the road, they go in the waterways, they kill the fish. So it's an unexpected environmental outcome of using rubber tires.